Exciting, exciting. This is the last section. Woo! 7.3 is on systems still, but instead of equations, it's now going to be inequalities. And inequalities, remember, do not use an equal sign. They use less than, greater than, less than or equal to, greater than or equal to. So all of our objectives today are going to be looking at how do solutions of inequalities work, whether they are linear or nonlinear, and what does a solution to a system of inequalities look like. That's going to be our goal to try and figure out. So let's first look at a linear inequality in two variables. So if it's linear, remember that means the highest exponent you'll see is 1. The graph of an inequality in two variables is the set of all points that satisfy the inequality. Okay, right, that makes a lot of sense, right? So what I want to show you, I don't believe this is in your notes, which is fine, but I just want to show you the difference between graphing an equation and graphing an inequality. So if I wanted to graph the line y equals 5, I would go to where y is 5, and remember that's a horizontal line. And that's my answer. That is the line y equals 5. Only where y is 5. Now, if I wanted to graph y is greater than or equal to 5, I would still graph my horizontal line at 5, except that's not the answer. If I said, hey, tell me something that's greater than or equal to 5, you could say 5 because that's equal to 5, or you could say 6, or 8, or 5,000, or 20.4. There's technically an infinite amount of answers that are greater than or equal to 5. So to represent that solution, I would literally shade everything above my line, meaning if an ordered pair lands somewhere in this shaded region, it will be a solution to y is greater than or equal to 5, because that would mean my y coordinate is above 5. If an ordered pair lands down here, anywhere down here that's not shaded, that means that ordered pair is not a solution, because the y value would be less than 5. So equations, they're short and sweet. If it's y equals 5, then it's only where y equals 5. But if you throw an inequality symbol in, today you're going to see us shade to indicate, hey, there's an infinite number of answers, and they are in this shaded area. So the thing I want you to really nail down today, the shaded area represents all the answers. The not shaded area represents, well, the not answers. That's really bad wording, but hopefully you know what I mean. So there are some steps that we can follow when we graph inequalities. So when you're graphing, you can think of it as replace the inequality symbol with equals and just graph. So think of it as we're just graphing an equation. So don't let the inequality symbol throw you off when it comes to graphing it. And if you're dealing with a line, it might be helpful to write it in slope-intercept form. Remember, that was mx plus b, because then it's really easy to graph. Now, one little detail, you're going to draw a solid line for your graph if you have the inequality symbols with the equal to bar under them. You're going to draw a dashed line if you have the inequality symbols but they do not have the equal to bar under them. When we do an example, I will tell you the purpose of that, what that means. And then sometimes this final thing is what people have the hardest time with. To figure out where the shading is going to be. Where are all my answers? What am I going to shade? you're going to choose I call it a test point, and we're going to substitute that into the inequality. When you substitute that test point in, if it comes out true, we are going to shade the region that contains that test point. So if my test point was 0, 0, and I plugged it in and it made the inequality come out true, I would want to shade wherever 0, 0 was. If when I substitute it in it comes out false, then I want to shade the region that does not contain the point. And when we do an example, you'll see what I mean by this. All right, so let's try one. So here, this is not a system of inequalities. This is just one inequality. So we're going to start off pretty basic. So if I want to graph this, let's get y alone first. So I'm going to subtract 2x. So then I have negative 3y is greater than or equal to, I'm going to write it as negative 2x plus 6. And then I would want to divide by negative 3. Now careful, remember with inequalities, when you multiply or divide by a negative, the symbol flips. This negative 2 over negative 3, it's going to become positive 2/3 x. And the last guy, 6 divided by negative 3, is minus 2. All right, so I want you to think we are in slope-intercept form, mx plus b. Remember, this is my slope, and this is my y-intercept. I want to begin at my y-intercept. So I'm going to begin when y is negative 2. And now I want to use my slope to make more points, so rise over run. I'm going to rise 2, run 3. Rise 2, run 3. Now, when I go to draw the line in, we have to decide, is this going to be a solid line or a dashed line? Because I have the equal to bar under my inequality, we want a solid line. Oops, I missed that point. Extend your line all the way across. And in just a moment, I'll tell you the purpose between the solid and dashed line. And now we're going to figure out our shading. So I basically have to decide, am I going to shade above the line or am I going to shade below the line? It will be one of those two regions. To help you with that, let's pick a test point. My test point, if I can get away with it, I always like to use 0, 0 because it's easy to work with. I don't care where you substitute it in. You could put it into the original or you can put it into the one where you got y alone. We'll put it into the one where I got y alone. So I'd get 0, 2/3 times 0 is 0, minus 2 is negative 2. So if you look at that, it says 0 is less than or equal to negative 2. Is that true? Does that make sense? No, that's false. That does not make sense. So what that means for my shading, I'll use my highlighter here. Since 0, 0 did not make this true, that means 0, 0 is not an answer. So I do not want 0, 0 in the shaded region. So I'm actually going to shade the region that does not contain 0, 0. This would be my answer. On my math lab, when you do the shading, it's going to give you a paint bucket, and you'll literally just click the region, and it will fill it in for you. Okay, so what does this mean? Well, it means any ordered pair that lands in this yellow region, if I plug it in to my lovely inequality, it will come out true. It will make sense. If I pick any ordered pair that's not in the shaded region, and I plug it into the inequality, it will be false, like what we saw with 0, 0. Why did I use a solid line? Well, that means if I pick any number that lands right on the line, it will cause it to be true. So a solid line represents we can use points right on it as well, and it will work. A dashed line would mean you don't want to land right on the line. We couldn't actually be equal to it. Another rule of thumb, you can actually, and some people don't like this way, you can skip the test point business and just know right away which side to shade. To do that, you have to look at where you got y alone. Notice how it said y is less than or equal to. Less than or equal to literally means below the line, less than the line. So that's why I shaded below. Let's try another one. So now this one, y is already alone. So if I think of it in slope-intercept form, here's m. What's b? Well, technically b is 0. There is no y-intercept. So we're going to begin on the y-axis at 0. And now I'm going to use my slope to make more points. Rise over run. So I'm going to put the negative with the 2. Either put it with the 2 or the 3, not both. So down 2, right 3. Down 2, right 3. Now notice on this one, there is no equal to bar. So that means we are going to have a dashed line. And again, the purpose of that means if the point lands right on the dashed line, it would not be a solution because I cannot be equal to. I strictly need to be greater than. Now, if you want to do the shading without even messing with the test point, think of it, y is greater than. Greater than means greater than the line, so literally it means above. Greater than the line, above the line. If that way confuses you, let's also quick review the test point. Now, I can't do 0, 0 as my test point this time because it's right on it. So I'm going to do 1, 1 as my test point. So if I plug 1 in and simplify, I get 1 is greater than negative 2/3. Does that make sense? Yes. So what that means, 1, 1 needs to be in the shaded region. It's an answer, and it is. Okay, if it causes it to come out true, it needs to be in the shaded region. Try another one. Y is already alone. So now this one is a unique line. Think of it as y equals negative 3. So if I go to where y is negative 3, this is going to be a horizontal line. And is it going to be solid or dashed? It should be solid because I do have the equal to bar. And now we have to decide the shading. Well, if I quick just look at it, it says y is less than or equal to. So less than or equal to, think less than the line. So that literally means below, under it. If you don't like that way, let's do a test point. I'm going to do 0, 0 as my test point. So if I plug 0 in for x and y, well, notice there's no x, so I'm just plugging it in for y. 0 is less than negative 3. Does that make sense? 0 is less than negative 3. No, that's false. So what that means, if I look at where 0, 0 is, since it's false, it better not be in the shaded region. If it's true, then it needs to be in the shaded region. So that works. It's not in the shaded region. Okay, let's try another one. This one is another unique line. Think of it as x equals 2. So I'm going to go to where x is 2, and this is a vertical line. Solid or dashed? Well, I don't have the equal to bar, so this is a dashed line. On MyMathLab, you'll want to make sure that before you graph the line, there will be 2 options you can select. You can either select the solid line or the dashed line. So make sure you select the one you want. And let's see if we can figure out the shading. I want to be greater than 2. So in this case, do you think greater than means left of the line or right of the line? Well, it means right of the line. These are where the numbers that are greater than 2 for x. If you don't like that way, let's do a test point. So I'm going to pick 0, 0. If I plug 0 in for the x and the y, well, there's only an x. 0 is greater than 2. Does that make sense? No, that's false. So that means 0, 0 better not be in the shaded region. All right. What about graphing nonlinear inequalities? So if they're nonlinear, remember that means the highest exponent I will see will be bigger than 1. So I'm going to see some squareds. So let's look at this first guy, graphing this first guy. This, if both x and y are squared, this is a circle. So let's go over how you graph a circle. So in a circle, let's think of it as being equals for now. The form of a circle, I'm going to write it up here and then we're going to talk about it. It looks intimidating, but the circle is one of the easiest things to graph. So in this form, you need to know 2 things about a circle. The center of the circle is HK, whatever H and K are. That's going to be the center. And the other thing you need to know about a circle is the radius. And the radius is going to be whatever R is. Just a visual here, a circle, here's the center, and then remember the radius is like the halfway distance. That's R. So on this example, let's see if we can figure out the center and the radius, because if you know those 2 things, you can graph the circle. So the center, well, I need to know what H and K are. If I look at this example, notice how there's no numbers being added or subtracted with the x and y's. So that means H and K are both 0. 0, 0. Now let's do the radius. In my formula, the radius is r squared. So if there's a 9 sitting there, what was r? Think of like square rooting 9. R had to be 3. Right? Because 3 squared is 9. I'm ready to graph the circle. So I'm going to plot a point at 0, 0. That's going to be the center of the circle. Now, here's what I want you to do to graph it. On my math lab, it will be easy because there's a circle tool. But on paper, since our radius is 3, we're going to go 3 away. So I'm going to go 3 to the right of the center. I'm going to go 3 up from the center. I'm going to go 3 left, and I'm going to go 3 down. We're ready to draw in the circle. Will this circle be solid or dashed? Well, because I have the equal to bar, it's going to be a solid circle. So do your best here. Ooh, that's not too bad. We have our circle. The last step is to figure out the shading. So I'm either going to be shading everything outside of the circle, or I'm going to be shading everything inside the circle. Let's do a test point to figure this out. I'm not going to do 0, 0. Let's do 1, 1. Let's see what happens. So if I plug 1 in for the x and I plug 1 in for the y, 1 squared is 1, 1 squared is 1, 1 plus 1 is 2. I get 2 is less than or equal to 9. Is that true or false? That's true. 2 is less than 9. Because it's true, that means my test point of 1, 1 needs to be in the shaded region. And since 1, 1 is inside the circle, my shaded region is the region inside the circle. All right, these last few examples are tying it into what we've been talking about this entire unit, this idea of systems. So a system of inequalities is more than one inequality. So let's graph this. Now both of these are linear, so they're both going to be lines. Before we graph them though, we might want to get y alone to make it easier. So this top guy here I'll do in red. I'm going to subtract x over, and then I have to divide by the -1 that's sitting in front of the y. So make sure the symbol flips when I divide by a negative. I now have a positive 1x minus 1. Let's graph this guy first before we worry about the other one. So mx plus b, I'm going to begin when y is -1, and my slope is technically 1, so 1 over 1, rise 1, run 1, up 1 over 1. And when I draw this line in, will it be solid or dashed? It should be dashed because I don't have the equal to bar. Now, I would not get carried away with the shading on this one, otherwise we'll have a big mess. So what I'm going to do, I'm just going to make myself a note of when the time comes to shade, where would I shade? So if I look at where I got y alone, it says y is greater than. Greater than the line would literally mean above it. So what I'm going to do, I'm just going to make myself a little note that when the time comes to shade, I want to shade above it. If you wanted to do a test point, if I did 0, 0 as my test point and I plugged that in, I'd get 0 is greater than -1, which is true. So that's why I'm shading the region where 0, 0 is. But I'm not going to do the shading yet. Okay, now let's do the other one. I'll do it in green. We need to get y alone, so I'm going to subtract the 2x. And then I have to divide the 3. So let's graph this line, mx plus b. So I'm going to begin at 4. And then my slope, I'm going to fall 2 and then right 3. Fall 2, right 3. When I graph this line, will it be solid or dashed? It should be solid because it has the equal to bar. Now notice, if this would have been a system of equations, my answer, my solution would have been their intersection. But this is inequalities, so we're dealing with entire regions. Let's figure out where we would shade for this green line. If I look at where I got y alone, it says y is greater than or equal to. So that would mean greater than the green line or above it. So I'm going to make myself a note. When the time comes to shade, I want to be above the green line. If I did a test point of 0, 0 just to confirm my shading, I'd get 0 is greater than 4. That is false. So that's why I'm shading away from 0, 0. So now your answer to this system, and this is why I didn't do the shading yet, your answer should be the common shaded region to both, the overlap. So if I look at my little blue arrows, I need to say above the red line and also above the green line. So my answer region is right here. It has to be the region where they would overlap. So that's why I don't do the shading until the end, otherwise you get a really big mess. So if I were to quiz you here, if a point lands anywhere in this yellow region, it is an answer to the entire system. It works in both. If an answer fell over here in this region, it would only be a solution to the red equation. If an answer fell over here in this region, it would only be an answer to the green inequality. And what about if an answer fell down here in this bottom region? What would it be an answer to? Neither. It wouldn't work for either. So our goal when we do these is to find the region that works for both, and that's what gets shaded. Okay, let's do another one. Now this one, I know I'm going to have a line. This is linear. This top one is not a circle because there's only one thing squared. If there's only one thing squared, that's a parabola. And remember, the parabolas look like a U shape. Well, let's do the parabola first, since y is already alone. To graph a parabola, I recommend, let's just make a quick table of values to get some points. And let's plot let's for sure do 0. So if I plug 0 in for x, I'd get -4 out. So let's plot that point. 1, 2, 3. 0, -4. Let's plot some other points. It would be really nice, and this is what you're going to have to do on MyMathLab. Let's figure out where it would cross the x-axis. So if I plug like 1 in, 1 squared minus 4, I'd get -3 out. 1, -3. Okay, that's not quite enough yet. What about if I plug 2 in? 2 squared minus 4. That would be 4. Ooh, that comes out to 0. So there's an x-intercept. It's really nice if you can get those x-intercepts. And remember, parabolas are symmetrical, so if I plug -1 in, -1 squared minus 4, that would be 1 minus 4. I get -3 out. So I'm going to get a mirror image here. So I'm ready to graph my parabola. Will it be solid or dashed? Should be solid because I have the equal to bar. Remember, it's just going to keep expanding. So there's my parabola. Let's figure out the shading on it. If I pick, well, you should be able to tell. Y is greater than, so that would literally mean greater than the parabola or above it. So that would actually be above it here. I'm just going to make myself a note. But if you wanted to do a test point, if I plugged 0, 0 in, I'd get 0 is greater than -4, which is true, meaning I would want 0, 0 to be in the shaded region. Okay, now let's do the line, which should be less work. I just have to get y alone first. So I'm going to subtract 2, or I mean subtract the x, sorry. Subtract the x over. And then I have to divide by a -1, which is going to cause the symbol to flip. So let's plot that line. I would begin at -2. And then my slope is 1, so up 1 over 1, up 1 over 1. And will this line be solid or dashed? It should be solid because I have the equal to bar. Oh, that's horrible. We're just going to retry that. Okay. If this was a system of equations, I can see my answers would be here and here, because that's where they intersected. But this is not. I'm looking for the common shaded region. So let's figure out where we would shade for this pink line. If I look at where I got y alone, y is less than. Less than the line would mean under it. Or you could do a test point and figure it out that way. So, where is the common region? I need to be above the red parabola, but below the pink line. My solution region is this little sliver right here. Above the red parabola, but below the pink line. Okay, let's look at this one. These are both lines because they are both linear. Highest exponent is 1. So these should go pretty quick. I'll do this first guy up here in blue. Let's get y alone. So I would have to subtract 2x over and then divide everything by 3. So let's graph that. I want to begin at 2, that's my y-intercept, and my slope down to right 3, down to right 3. Solid or dashed line. Solid. And now let's figure out the shading. If I look at where I got y alone, it says y is greater than. Greater than would mean greater than the line, or in this case, above it. If you don't like that way, let's quick do a test point. I'll do 0, 0. So I get 0 that'd be 0 plus 2. I'd get 0 is greater than or equal to 2. Is that true or false? That's false. So that's why I'm shading away from 0, 0. I don't want to include it. Okay, now let's do the other guy. I'll do it in pink. So again, I'm going to subtract my 2x over. And then I'm going to divide by 3. So this one, technically my y-intercept is 0. There's a plus 0 out back, so I'll start at 0. And then I'm going to go down to right 3. Down to right 3, and this will also be a solid line. And now let's figure out its shading. If I look at where I got y alone, I want y to be less than, which would mean less than the line, or below it. Or you could do a test point to figure that out. So where is the solution to this system of inequalities? Where is the overlap? I have to stay below the pink line but above the blue line. Well, there isn't an overlap. There are parallel lines. I will never have a region common to both of them at the same time. So this is a big fat no solution. There is not a set of ordered pairs that will work for both of them at the same time. All right, last example, grand finale. This is a system of 3 inequalities, and if you can do what we were just doing, one more doesn't make it any more difficult. And these, good news, these are all lines. So, let's do the first one. I'll do it in red. Sometimes I found if I color code these, it kind of helps keep things straight. So let's subtract x. And then I have to divide by a -1. Symbol's going to flip because we're dividing by a negative. So I get positive x minus 2. Let's graph that guy first. So I want to begin at my y-intercept of -2. And my slope is technically 1, so 1 over 1. Up 1 over 1, up 1 over 1. When I graph this line, will it be solid or dashed? It should be dashed because I don't have the equal to bar. And now let's figure out where would this get shaded. Well, if I look at where I got y alone, y is greater than, which would mean greater than the line or above. By the way, if you're doing this little trick where you don't do a test point and you just look at it, you have to look at where y is alone for this trick to work. You can't look at the original. You have to look where y is alone. If I did a test point, I'd get 0 is greater than -2, which that's true. So I would want 0, 0 to be in the shaded region. Great. All right, so that one's done. Let's look at the next one here. I'll do it in, let's do purple. This one's tricky because it says -2 is less than or equal to x is less than 4. What does that mean? Well, it's basically saying x is between -2 and 4. So visually, how I would show that on my graph, let's go to where x is -2 and make a vertical line. Will it be solid or dashed? Well, the one going through -2 should be solid because it has the equal to bar. And then I'm going to go to where x is 4, 2, 3, 4, and I'm going to make a vertical line. Will it be solid or dashed? This one should be dashed because it doesn't have the equal to bar. And again, what I told you, x is between -2 and 4. So when it comes time for the shading, I want to stay right of this line, but left of the other. I want to stay between them, is what that means. So it kind of looks worse than what it is. You're just staying between them. Think of it as two walls. And then finally, let's do this last guy in green. That's just, think of it as y equals 3. So I'm going to go to where y is 3, and I'm going to make my horizontal line. Will it be solid or dashed? Should be dashed all the way across because I don't have the equal to bar. And for this green one, do I want to shade above or below it? Well, it says y is less than 3. Less than 3 would be below it. Okay, so we kind of got a mess here, but now your job is to find the common region that works for all of them. So I need to stay above red, between the purple, and below green. Where is that region? You should identify it as, it's this like trapezoid looking shape right here. That would be the solution to all three inequalities at the same exact time. So, word of advice on My Math Lab, make sure that if you want a solid line, that you have clicked the solid line tool. If you want a dashed line, make sure you've clicked the dashed line tool. That sometimes gets people tripped up.